Hey guys, we are graphing this polynomial today, okay? Exciting things happening. It's like Christmas, okay? Now, first of all, whenever we graph something, we always have the option of picking a number for x, plugging it in, getting a y, graphing that ordered pair, right? We always have that option. But it can get tricky. We don't always know what to plug in, how many points to plug in, all of those things to get a good shape of the graph, okay? So I'm going to give you some steps here that help us find the shape of this graph pretty quickly. Okay, so the first step is we're going to factor if we need to and find the zeros. Okay, second step is we are going to figure out our end behavior of our graph. Third step is multiplicities, and then we have an optional fourth step that we'll talk about when we get there. Okay, so first step is factoring and finding the zeros. Well, guess what? We already factored here. Isn't that nice? We are factored. Now, finding our zeros, we want to know where the graph crosses the x-axis, right? So to do that, what I would do would be to set this whole thing equal to 0, right? Which in turn ends up, you're just setting each thing equal to 0, right? So I could set 2 equal to 0, but that's just not true. It doesn't matter, right? So we don't really need to worry about that one. Then I'm going to set x minus 4 equal to 0, okay? So we are finding our zeros here. I'm setting x equals 4. Oh, sorry. Did I say x equals 4? Sorry. I meant x minus 4 equal to 0. Sorry if I said that wrong. So we're setting x minus 4 equal to 0. Okay. So obviously I add 4 to both sides and end up with x equals 4. Okay. Then I'm going to make a little note here that if I were to write this out the long way, there would be 2 x minus 4s, right? Because I have that x minus 4 squared. So I'm just going to make a note here. This is what we call a multiplicity of 2. Okay, making a note, that'll come into play in a minute. Okay, now I'm setting this guy equal to 0. I'm going to circle him so we know. Okay, x plus 2 equals 0, which when I subtract 2 from both sides, I get x equals negative 2. Okay, then I'm going to set x plus 5 equal to 0. I subtract 5 from both sides and get x equals negative 5. Okay. So remember, this is when I set y equal to 0. So this is where my graph crosses the x-axis, okay? So I'm going to cross at 1, 2, 3, 4, at negative 2, and at negative 1, 2, 3, 4, 5, okay? That is where I know my graph crosses the x-axis, but what does the graph do, right? Like, what does it look like? So the next thing, second step we're going to figure out is our end behavior, okay? I got a little paper for people who like to read. If you don't like to read, just ignore this for half a second, okay? If this helps you, take a screenshot, okay? So we're going to figure out what the right side of our graph does, if it goes up or down, and same thing with the left side of our graph, okay? So first of all, the right side. To know what the right side of our graph does, we look at our leading coefficient. And all we care about right now is if it's positive or negative, okay? If it's positive, my graph ends up. If it's negative, you guessed it, my graph ends down. So 2 is positive, so that means my graph is going to end up. So I'm just going to do a little pencil mark here. I know my graph ends up, okay? Then we need to know what the left side of our graph does. Does it end up or down, okay? Now, to know what this one does, we look at our degree, okay? Which means our highest exponent. So you might think when looking at this, oh, well, my highest exponent is 2, right? But right now we're factored. I need to know what the degree or the highest exponent would be when this is all multiplied together, okay? So basically, I would have 2x's here. If I were to multiply to everything, I would end up, my highest one would be x to the 4th, right? Because I have these 2x's, because it's squared, this x and this x. So if I were to multiply that all out, my highest exponent would be x to the 4th, okay? But all we really care about is if it's even or odd, okay? If my highest exponent is even, the left side of my graph is going to end the same way the right side did. So it would be up and up, okay? If it is odd, it's going to end the opposite way. So if this one's up, it would be down, vice versa. Okay, so this one is even. If I were to multiply these all out, my highest would be x to the 4th, right? So it's even, meaning the left side of my graph is also going to end up, same as my right side, okay? So Now what? We know what the end behavior is. My third step is looking at my multiplicities, okay? So we noted here that there were really two x minus 4s, right? So I could have x equals 4 twice, having a multiplicity of 2, right? What that means is if you have an even multiplicity, okay, 2, 4, 6, 8, that means the graph is going to bounce on that point, not go through, okay? If you have an odd multiplicity, it's going to go through. And if it can kind of change exactly how it goes through, but at this point your teacher probably doesn't really care about that. And if they do, you can talk to them about it, okay? But we are just going to, for the sake of this just kind of rough sketch, general sketch, when it's an odd multiplicity, the graph goes through the point. When it's an even multiplicity, it bounces, okay? So what does that mean? That means here at 4, instead of the graph going through, it's going to bounce, whether it's up or down. In this case, since I know the right side is going up, I know it's going to bounce that way, okay? So this is where I just kind of look. These ones just had a multiplicity of 1. So we're going to go through this point, and then bounce off that guy, okay? My printer just started making noises. Okay, all right, I think we're okay. So my graph is going to go like this, something like this. I don't know what my printer's doing. Okay, my printer just told me it was out of paper, and I'm not sure why it chose this exact moment, but there we go. Because these 2 points, -5 and -2, had a multiplicity of 1, an odd, it went right through, right? Because this one had a multiplicity of 2, an even multiplicity, it bounced off that. And because I already figured out my end behavior, I knew they both ended up, okay? All right, my optional 4th step would be to plug in some more points, okay? You would want to do this before you drew the graph, actually. But basically, the reason I didn't put tick marks on my y-axis was because I don't know exactly how far down and up these curves go, right? And for the general graph we're doing, it probably doesn't really matter at this point in time. That's something that if you move on to calculus, you will learn more about. But at this point in time, I don't need to worry about it too much. But if you do want to know these points, where this crosses the y-axis, you can always plug in points to figure out if you want to. Okay, so that's that optional 4th step if you so desire. Okay, all right, but I hope this made sense. I will link some more examples if you need them. Thanks.